Welcome to my YouTube channel. Today I will discuss about a very important criteria, which is Eigenstein's irreducible criteria. This theorem tells us about a function fx which is reducible or irreducible, which tells us the irreducibility of fx in a certain domain. What that theorem is, let fx is a non-constant polynomial a0 plus a1x plus a2x square plus ... a n x to the power n. It is a non-constant polynomial in zx. If there exists a prime p, such that p will divide all the coefficients a0, a1, a2, an minus 1, p will divide all the ai's except the leading coefficient an. That is, p divide ai for I equal to 0, 1, 2, n minus 1. That means this will divide a0, a1, a2, an minus 1. P does not divide an, and p square does not divide a0. P square does not divide the constant coefficient. Then fx is irreducible over the quotient field of z, that is qx. Basically, the criteria is, if fx is something like that, a0 a1x plus a2x square plus an x to the power n, where a0 a1 ans belonging to an UFD, and UFD, then fx is a, and if there exists a prime p such that p will divide all the ai's except an, and p square does not divide a0, then fx is irreducible over q dx. If d is that UFD, then fx is irreducible over q dx. We all know that z is an UFD, zk UFD, and its quotient field qd, if d is equals to z, then qd is equals to q. So fx is irreducible over qx. And also again, if fx is a primitive polynomial, that means the GCD of a0, a1, an equal to 1. If fx is a primitive polynomial in zx, then fx, and there exists a prime p, that p will satisfy all the conditions 1 to 3, then fx is irreducible in zx, not only qx. It is also irreducible in qx, but more specifically we say that fx is irreducible in zx. Okay, this is Eigenstein irreducibility criteria. And now we will discuss some problems with the help of Eigenstein irreducibility criteria. Problem: so that fx is equals to x to the power 5 plus 15x cube plus 10x plus 5 is irreducible in zx. So, solution. Here, if we compare fx is equals to, if we compare the given problem, the given equation with fx is equals to a0 plus a1x plus a2x square plus a3x cube plus a4x to the power 4 plus a5x to the power 5, then a naught is equals to the constant term 5, a1 is equals to 10, a2 is equals to 0, there is no term of x square, a3 is equals to 15, a4 is equals to 0, no term of x to the power 4, and a5 is equals to 1, the leading coefficient. So GCD of a0, a1, a2, a3, a4, a5 is equals to 1, because a5 is equals to 1, a0 is equals to 5, a1 is equals to 10, 0, a3 is equals to 15, 0, 1. So since it's 1, so GCD is 1. So fx is a primitive polynomial, is a primitive polynomial. Now if we take p is equals to 5, then p is a prime, p is prime. Number 1, p will divide a0 is equals to 5, a1 is equals to 10, a2 0, p will divide, 5 will divide 0, a3 15, so 5 will divide 15, a3, a4 0, so 5 will divide 0, so a4. Number 2, p is equals to 5 does not divide the a5, which is equals to 1. So p is equals to 5 does not divide a5, is equals to 1. Number 3, p is equals to p square is equals to 25 does not divide the constant term, that is a0 is equals to, does not divide, is equals to a0. So p square does not divide a naught. So p will divide, this is 5, this is 10, this is 0, this is 15, and this is 0. So p will. Problem: 5px is equals to 1 plus x square plus dot dot x to the power p minus 1 is equals to x to the power p minus 1 by x minus 1 is irreducible in Zx. P is prime. So I have to show that 5px is irreducible over Z, where p is prime. This 5px is called the cyclotomic polynomial. It is called the cyclotomic polynomial, and cyclotomic polynomial where p is prime is irreducible in Zx. So let's start a solution. Here GCD of all the coefficients, GCD of all the coefficient is 0, is 1, because all are 1, so GCD is 1. So content of phi px is 1, hence it is primitive, hence it is primitive polynomial. Okay. Let, if possible, we prove, let phi p is reducible, not irreducible. Irreducible. So there exist two non-unit polynomial, two non-constant polynomial, that is non-unit polynomial hx and gx such that if possible let phi px is reducible, such that phi px is equals to hx into gx. Okay, so here if we put x plus 1 for x, then it will give us that h of x plus 1 into g of x plus 1. Now phi p of x plus 1 is equals to phi p of x is equals to x to the power p minus 1 by x minus 1. So it will be x plus 1 whole to the power p minus 1 divided by x minus 1. Sorry, x plus 1 minus 1. It is phi p of x plus 1 is equals to 1 plus px plus pc2x square plus dot plus pci x to the power I plus dot last term is x to the power p minus 1 divided by x plus 1 minus 1, that is x. That is 1 and minus 1 will cancel out. So the term will be p plus pc2 x square plus dot pci x to the power I minus 1 plus dot x to the power p minus 1. So here p a prime given divides all the coefficients, all the coefficients p, pci, all the coefficients p, pc2, pc3 dot pci, and the second last term, the coefficient of the second last term, which is also pc p minus 1, that is equals to p, but does not divide the coefficient of x to the power p minus 1 because it is 1. But P does not divide the coefficient of x to the leading term, x to the power p minus 1, that is 1. So P does not divide 1, and P square does not divide the P, the constant coefficient, constant coefficient, that is a naught, we call it there before a0. So P does not divide P. So P, so the prime P satisfies all the three conditions of Eigenstain criteria. Eigenstain criteria. Hence, phi p x plus 1 is irreducible over zx. Hence, phi p x plus 1 is irreducible over z, because phi px is a primitive. So phi px plus 1 also primitive, and phi px plus 1 because phi px plus 1 is primitive because the GCD of p, pc2, pci and 1 is equals to 1. Okay, so phi px plus 1 is irreducible over z in zx, over z, that is in zx, as the content of phi px, that is GCD of the coefficient p, pc2, pci dot at 1 is equals to 1, and hence phi px, and hence phi px is irreducible in zx, as phi px is primitive one, is primitive polynomial. So this completes the solution. Now a problem, let fx is equals to x to the power 6 plus x cube plus 1 belongs to zx, then show that fx is irreducible over q and z, that is irreducible in qx and zx. Solution: here fx is equals to x to the power 6 plus x cube plus 1 belongs to, this is belongs to zx, this belongs to zx. Now f of x plus 1 is equals to x plus 1 whole to the power 6 plus x plus 1 whole to the power 3 is plus 1, and this is, we write 3 plus 9x plus 18x square plus 21x cube plus 15x to the power 4 plus 6 x to the power 5. If we simplify this, we get this x to the power 6. So compare this, compare fx, compare with fx is equals to a0 plus a1x plus a2x square plus a3 x cube plus a4x to the power 4 plus a5x to the power 5 plus a6x to the power 6. Then a0 is equals to 3, a1 is equals to 9, a2 is equals to 18, a3 is equals to 21, a4 is equals to 15, a5 is equals to 6, and a6 is equals to 1. Then GCD of a0, a1, a6 is equals to 1. So f of x plus 1 is primitive, as well as fx is also primitive. So f of x plus 1 is primitive polynomial in ZX. Let us take the prime p is equals to 3. Then definitely 3 is equals to p will divide a is a0, a1, a2, a5, but a6 is equals to 1. a6 is equals to 1, so p does not divide. So number 1, number 2, 3 is equals to p does not divide, 1 is equals to a6. Number 3, p square is equals to 9 does not divide, 3 is equals to a0. So p square does not divide, which implies p does not divide a6, which implies p square does not divide a0. So all the three conditions hold. All the three conditions hold for p is equals to 3. So f of x plus 1 is irreducible in qx and zx, and hence if x is irreducible in qx and zx. That's all of the solution. So thank you, and please subscribe my channel Somu's Class. Thank you very much.